Practical comparison test limit method. If f and phi are the positive in closed interval a to t, and first limit t tends to infinity, f of x upon phi x equals to L, where L is a non-zero finite number, then the two integrals, integral a to infinity f of x dx and integral a to infinity phi x dx converges or diverges together. Second, if limit t tends to infinity, f of x upon phi x equals to 0 and integral a to infinity phi x dx converges, then integral a to infinity f of x dx also converges. Third, if limit x tend to infinity, f of x upon phi x equals to infinity and integral a to infinity phi x dx diverges, then integral a to infinity f of x dx also diverges. Proof. First, clearly L is greater than 0, taking epsilon greater than equal to 0 such that L minus epsilon is greater than 0. Since limit x tends to infinity, f of x upon phi x equals to L, so there exists a number k greater than a, however large, such that for x is greater than k, modulus f of x upon phi x minus L is less than epsilon, or L minus epsilon into phi x is less than f of x is less than L plus epsilon into phi x. Equation 1. Now L minus epsilon into phi x is less than f of x for all values of x is greater than k is greater than a. So integral k to infinity f of x dx converges. Then by the direct comparison test, integral k to infinity phi x dx, hence integral a to infinity phi x dx converges at infinity. Again, from 1, f of x is less than L plus epsilon into phi x for all values of x is greater than k is greater than a. So if integral k to infinity f of x diverges, then by the comparison test, integral k to infinity phi x dx and hence integral a to infinity phi x dx diverges at infinity. Second, because limit t tend to infinity, f of x upon phi x equals to 0, so there exists k such that f of x upon phi x is less than epsilon for all values of x is greater than k. So f of x is less than epsilon phi x for all values of x is greater than k. So if integral a to infinity phi x dx converges, then integral a to infinity f of x dx also converges. Third, because the limit f of x upon phi x equals to infinity, so there exist k and m such that f of x upon phi x is greater than m, or f of x is greater than m phi x for all values of m phi x, and for all values of x is greater than equal to k. So if integral a to infinity f of x phi x diverges, then integral a to infinity f of x dx also diverges.